Welcome back to Explaining Everything, the channel where we dive into the stories and mysteries behind everyday things. Today's question comes from a viewer named Bananarchist 47. Thanks for the suggestion, Bananarchist. Great username, by the way. You asked, why do some fruits ripen faster next to bananas? Are bananas secretly radioactive or something? Now, your apple wasn't zapped by radiation, cursed, or recruited by the banana into some kind of fruity rebellion, but it was chemically peer-pressured into ripening. Yes, fruits can be dramatic like that. So today, we're answering this surprisingly juicy question right here on Explaining Everything. Let's start with a little behind-the-scenes fruit biology. Fruits don't just wake up one day and decide, you know what? I'm ripe now. Let's do this. Nope. Ripening is a coordinated chemical process, a mix of sugars forming, acids breaking down, cell walls softening, and colors changing. Think of ripening like a fruit's version of puberty, but faster and with less angst. Usually. And the secret ingredient behind this transformation, a gas called ethylene. Ethylene is a tiny, invisible molecule that acts like a hormone for plants. Some call it the ripening gas, but I like to think of it as the drama stirrer of the fruit world. When a fruit starts producing ethylene, it's basically announcing to its neighbors, hey, I'm getting ripe over here. And if those neighbors are the kind that also respond to ethylene, they'll start ripening too, like a synchronized boy band doing a key change. Bananas, my friend, are ethylene superstars. They pump out this gas like they're getting paid for it. They produce so much ethylene, it's honestly a little rude. It's like if someone brought an air horn to a silent yoga retreat. So if you put an ethylene-sensitive fruit, say an apple, avocado, or peach next to a banana, it's going to get blasted with ethylene, and it will ripen much faster than if it had been chilling solo in the fruit bowl. Here's where things get even nerdier and kind of weirdly specific. Fruits are generally split into two categories, climacteric and non-climacteric. Climacteric fruits are the ones that keep ripening after they're picked. They're the ones that react to ethylene like it's a double espresso. This includes bananas, apples, pears, peaches, mangoes, and avocados. Non-climacteric fruits, on the other hand, do not keep ripening after harvest. They just plateau. No glow up, no transformation montage. What you pick is what you get. This group includes strawberries, grapes, pineapples, and citrus fruits. So if you try putting a banana next to a lemon, nothing's going to happen. The lemon doesn't care. It's like, cool story, banana. I peeked in the orchard. So why are bananas so intense about ethylene? Well, once a banana starts ripening, say a little bruise or soft spot, it begins producing ethylene like crazy. That ethylene then makes other parts of the banana ripen even faster, and also tells nearby fruit, get it together, we're ripening now. It's like a positive feedback loop of fruity panic. Bananas are also often picked green, and then artificially ripened during shipping or storage using, you guessed it, ethylene gas. So they're already primed to be ripening machines by the time they reach your kitchen. Wait, so is ethylene bad? Not at all. Ethylene isn't some evil fruit villain. It's just a little extra. In agriculture, ethylene is actually used on purpose. Commercial growers use controlled ethylene exposure to ripen fruits uniformly before shipping to stores. It's one of the reasons you can buy perfectly yellow bananas or ripe-looking tomatoes even when they've traveled thousands of miles. So, while your banana might seem like a little fruit saboteur in your kitchen, it's just doing what bananas do. So, are fruits talking to each other? Sort of, yeah. Through gas, which is both gross and amazing. Ethylene isn't just about ripening. In the wild, it helps coordinate plant development. When one fruit ripens, ethylene can spread to others and ensure that the whole plant matures together. That's useful if you're, say, a tree trying to get all your seeds eaten and dispersed by animals at the same time. So yes, in a weird way, fruits do communicate. But they do it with airborne chemistry instead of words. So to recap, your banana is not cursed. It's just gassy. And if other fruits are in the vicinity, they're going to feel the effects fast. Ethylene is the invisible MVP of the ripening process, and bananas are its loudest cheerleaders. So the next time you see your apple softening too soon, don't blame time. Blame the banana next to it, whispering, "You should totally ripen right now." If you enjoyed this fruity investigation, don't forget to like, subscribe, and maybe keep your apples socially distanced from your bananas, just in case. Also, if you have suggestions for our next video, feel free to share them in the comments below. We'll be sure to give you an acknowledgement for your contribution. Thank you for tuning in, and join us next time here in the channel that answers all the why, what, who, where, and how questions you've always wondered about, here on Explaining Everything.